Another pretty useful application of bit shifting can be found in a program where we need to display binary bits. Essentially, we need to display bytes of ASCII strings in a binary format, right? So we need to be able to print the value stored in a register, for example, and display each individual bit value as ASCII codes that are printable as 0 and 1. But since we're gonna need to print everything from left to right, we need to start with the highest bit. And so what we can do is pretty much use shift left to push the leftmost bit into the carry flag, then examine the carry flag and produce the corresponding output. So here's the possibility that we'll display bits in register EAX. So let's try this in our code. And what's suggested here is that we use the value and a buffer. Okay, so this is our data. And we have some sort of bit pattern stored for the sake of example, and we call this integer value in memory, and we can use, of course, 32-bit size output buffer because we're going to be needing to display 32 bits of this double word, and also we use the 33rd byte, which is 0, just to make sure that we have a 0 terminating string when we print using our input-output facilities. Okay, so instead of writing this code directly inside my main procedure, I would like to call a subroutine, right, a procedure, which I can call something like register EAX into bit buffer. Okay, so we have this bit buffer right here, and we're going to essentially use this bit buffer to display the results of conversion to string. So this will be here our procedure. So we need to say that this is our procedure proc, right? And procedure needs end p at the end, and of course we will return. And so the idea here is to essentially to convert EAX, right? So I'll just add a comment right here. Procedure to convert EAX to bits in a bit buffer. In fact, let's rename this to be bit buffer, something like this, just to indicate that that's the idea of this buffer, to contain a string with these values. And so what can we do here? Well, first of all, we can start by doing what we do is just to move into register EAX the value to display. So this we can do before calling the procedure. So because our procedure will expect EAX to be loaded with this thing. And of course, when I write my code, I prefer to use the labels referring to memory inside square brackets. It's just a reminder that this is something in memory, a double word stored in memory. And value, of course, is the label that represents location of this double word in the data segment. So what we can do here in our actual procedure is the rest of what's here, right? So we can do it like this. Copy all of this into our procedure. Okay, and let's see how this looks like. I just do my adjustments for the indentation like this. So now this is procedure, and this is what is being proposed to us. So we load register ECX with a number of bits in register EAX. Of course, it's a 32-bit register. So then we load, I renamed our buffer to be bit buffer, so I'm just going to use that as well. Bit buffer. And so what we can do? We can shift left this register, right? So we have this register. Let's talk about this. This is register EAX right here. And this is, of course, the set of bits that we'd like to display. So we shift left. So the leftmost bit is going to be shifted into the carry flag, right? The rest of the bits are shifted to the left as expected, and the lowest one is filled with 0. Okay, standard shift left logic. So then we say display 0 by default. So basically, let's assume that that carry flag is a 0, and then we say if not carry, we're all done. We can move to the next byte to fill in the buffer. So register ESI. So let's visualize this bit buffer. So there are like 32 bytes over here. This is all bytes. And so initially we load ESI with the location of the first byte right here. So here we move 0 into this byte, right? So we already load this byte with 0. And notice that this is 0 ASCII character 0 because it's enclosed in single quotes. So if no carry, which means that the carry flag got 0, this means that we're all done. Otherwise, we replace 0 with the 1, right? So we just override it the second time and say, actually, we want to have 0 right here. Replace it with the 1. Replace 0 with the 1 because the carry flag was set. So we're just making this switch by the conditional jump if not carry. And then we increment ESI, which will move on to the next byte in our bit buffer. And then we'll simply use loop instruction, right? Loop instruction to move to the go to the next bit, which will continue shifting again. So now the second time we shift again, the rightmost is filled with 0. We get our next bit in carry flag, and we'll again try to play this game with 0 and 1, and based on the carry value, be filling it in. So essentially this, as we shift to the left and push everything into the carry flag, we'll be filling in the string of 32 characters, and in the end we have the 0 terminating character in this buffer. And by the time we're done with this loop, by the way, loop decrements ECX, and as soon as ECX becomes 0, loop terminates, and we return from here. So this is the logic of this procedure. So after calling this procedure, what we can do is essentially output. We already have included this, and output this bit buffer and print binary digits as a string of characters. Display a new line and then return. Now end line here we need to define, and I'll likely want to save it of course in our constant segment. So this will be a byte, carriage return, line feed, and then 0. Okay, so this should be all set. I think we can give it a try. So let's try building this. Okay, and if I run this program, I press Ctrl F5 to run it. Yeah, so this is what it's trying to display. Okay, so of course, if you compare this binary number with this bit pattern, the lowest portion here is D, which is 1101. So this is hexadecimal D, which is 1101, and the highest 4 bits are 001, which is 1. So this 1 right here corresponds to this portion, 001. So it seems to be working okay.